Scientific advances typically proceed by primary research findings getting incorporated into clinical practices, resulting in new treatments and improved outcomes. Unfortunately, in autism research, we too often get stuck in a loop. Clinical criteria inform and even steer scientific practices, which too rarely result in new treatments. But new advances in behavioral analyses and the potential of personalized medicine have given autism researchers the opportunity to get it right, the opportunity to generate primary research findings, incorporate them into clinical practices, and create personalized treatments and improve outcomes for those with autism. Current behavioral analyses in autism science rely on observation and description of behaviors that are predictable and easy to detect. Clinical inventories like the Autism Diagnostics Observation Schedule score a child based on expected aspects of behaviors. These data are useful, but subtle, spontaneous aspects of natural behaviors, which are more variable and less predictable, remain hidden. These hidden aspects of behavior may hold important keys for personalized treatments. In our lab at Rutgers University, we have combined these ratings with those generated by wearable biosensors from off-the-shelf technology such as smartwatches and phones. These two complementary data sources allow us to improve diagnosis. We can make data collection less invasive, which reduces the burden on the autistic child, lower the rate of false positives by using empirically derived statistics rather than assumed models, shorten the time to diagnosis, and make diagnoses more reliable and truly reproducible across raters from different labs. These improved diagnoses can then be used to increase our understanding. We can stratify the main subtypes of autism, build age-appropriate statistics that measure rates of change as the person ages, track and separate the age progression of the disorder from the treatment's effectiveness, and train clinicians to read subtle body language and give pre-verbal kids a chance to use their body language and speak to clinicians. Finally, we can use this understanding to improve treatments. We can adapt the current autistic interventions in an age-dependent manner, create neuroprotective therapies, slow down the progression of neurodegeneration, and dampen the symptoms of Parkinsonism that we see in 20% of the aging autistic population right after 40 years of age. Together, behavioral scientists and behavioral clinicians can bring the science of autism to a level of rigor that allows open exchange, enhances reproducibility, creates new objective measures of effectiveness, and revolutionizes treatments of autism. For more information, visit us online